So last time we have discussed a relatively interesting and surprising phenomenon, which is related with the contagion of very different social behaviors within a society. It can be contagion of, in terms of buying some products. It may be contagion in terms of adopting a certain ideology or a certain behavior. It can, and we had in fact quite a number of examples, and in each of them the paradigm was that you have a network in which the nodes can be very different things, like citizens, but also innovations or ideas or feelings. And that these nodes, they are interacting. So, for instance, different citizens, if they are connected by a link in the network, then they can inform one another. Or customers can recommend a certain product which they have just purchased to another customer. Or an innovation which was just made can initiate the idea for another innovation which then becomes activated, and you have innovation cascades. And of course also in terms of ideas or even religious beliefs, and even in terms of feelings. And the important thing is that even though what you are putting in the model is just interactions between two persons, so it's in our language it's a microscopic information. It's you are just saying, okay, if two people are living one next to the other and one of them buys an air conditioner, there is a high probability that the other one might buy two. But the important thing is that once you have these microscopic mechanisms, they can concretize themselves into macroscopic effects. So in particular, a certain feeling by a person that the economy is going to go down, or that it's going to be crash, if he communicates to its neighbor in a convincing way, and if the right conditions are fulfilled, then this kind of hearsay can go on and in fact leads to a crash. And we have seen that mathematically speaking, indeed, if you consider as a parameter the density of people which are likely to be influenced by such a thought that there might be a crash, above a certain density, you have a phase transition between a situation in which there is a very limited number of people which are worried, and between a situation in which indeed the entire economy or a very large part of it becomes panicked, and you have a macroscopic effect emerging from this kind of microscopic interactions. And this is the kind of things which we have discussed. So in particular, in economics, there are two disciplines which, before this kind of works, they were considered as very different specialities. Somebody which was a specialist in microeconomics would not be very active in publishing in macroeconomics journals, and the opposite. And sometimes they were, this kind of, and even when an effort was made in order to connect microeconomics to macroeconomics, the effort was characterized in terms of, say, assuming that there is some kind of representative agent which is a macroscopic variable and which is essentially behaving at the macroscopic scale in the same way in which one sees that the microscopic individuals, the normal individuals, are behaving. While we see here that it's not so, because you might have a situation in which the microscopic individuals are behaving in a rather smooth way, in which their level of worthiness, of panic. It's varying slowly, but there is a certain point, a certain density, which the slightest change in it makes the difference between this behavior, these worries of the people at the microscopic level are not represented at all at the macroscopic level, and after the phase transition they are represented in a very dramatic way. So this was the kind of ideas, and these ideas started to be applied in different domains. For instance, by looking of how different products appear in the same time in different locations, let's say how different products are exported by the same countries, you can make a map in which the distances between the different products are representing essentially their similarity. Somewhat you hope that if they are appearing in the same places, they require the same capabilities to be produced, and then you expect that if one appears, then the next one will follow. This kind of ideas were advanced by Ricardo Hausmann. He even had this metaphor of monkeys, which are these different products, which you see they are listed here. You can have more detailed characteristic of the different products, but the point is that he was thinking in terms of these products being like trees, and a monkey, which is the one which would actually adopt this product or produce this product, would be able to get from one product from the other, like a monkey jumps from one tree from another. And therefore you would not expect somebody in a country in which let's say they are specialists in mining, that out of a sudden they will be able to make high-speed chips, computer chips. Rather, you would maybe expect that they would, since mining requires making big holes in the earth and making scaffoldings, you would expect maybe them to become next time become adept in making houses or things like that. So this concept of spreading, of contagion, one could hope to apply it to this kind of product spaces. And this is a product space which actually we computed based on our data from Italy, in which we had all these characteristics of who produces what and in which place and with whom, which are the suppliers and which are the clients of certain companies. However, what it turned out, that in fact, if you try to say, okay, so how can I use this kind of things? I can use it by saying, okay, so if I know that the product, some product is produced in Italy, and immediately after that some other product appears, maybe the same thing would be replayed or will happen to some country which is a little bit behind Italy, and therefore I can predict how that other country is behaving. Unfortunately, this kind of situation does not in general happens, and in particular it's because even if you have the capability to make some products in an economy, it is not clear at all that you would want to produce such products. For instance, in Israel, we did have for a very long while a tradition of producing clothings, simple clothings like white underwear, and you might say, okay, so this could develop in making more and more types of simple white underwear, but this is actually not happening. What happened is, in fact, that the production of such stuff, the entire factories are being moved in some other countries because this kind of production is not capable of paying to the workers enough money to live in a society in which one has every few weeks an exit of $1 billion in high tech. So there are these problems, and on top of this, the network itself it's not stable. So this brings us. Of course, if you think in terms of influence of companies, one or the other, in terms of, let's say, hoping that if you measure that some of the clients of a company are growing their production or lowering their production or their orders, then you can maybe hope to predict whether that company itself will have to lower its production as a response to that. And we have measured it, and the results weren't very strong as one expected. And then we started to understand why. This graph, it's showing the number of firms in Italy in different years. And of course, this is 2007. It's a border between 2007 and 2008. And it is where one starts seeing the effect of the crisis. And you see that there is a very dramatic change in the number of companies and also in the number of links which they have with one another. Of course, if a company disappears, then all the links of its clients or of its suppliers with it are disappearing. So the network itself is changing, and in fact, we have found that if you look at the companies which keep their network environment, they are they are in fact sensitive to their neighbors. But most of the companies, if they lose some customer, they will just look for another customers, and then you don't see any correlation between the any contagion of the type that I was advocating until now. So this brings us to the issue of reinterpreting our thinking about how to think in terms of nodes and links and networks. And in place of thinking about a static network in which you have some dynamics taking place on its nodes, like for instance, a certain industry exists there, it's connected very strongly to its similar industries, and the only difference is whether this industry is activated or not, and whether it will activate its neighbors or not. And this, I'm saying this is not something which turned out to be very productive, and rather one should reinterpret in terms of thinking about nodes which pre-exist there and are being activated by contagion. One should think rather in terms of creation of new nodes as they are appearing because of the dynamics of the network itself. So instead of a dynamics on the network, we are going to speak about dynamics of the network, of a network which itself is changing. An example which lately starts to be important because people are identifying, and we were even measuring this in some works which I'm going to speak about in the next lecture. The main tool for an economy to get out of crisis is innovation. And then, therefore, the cascades of innovation, how an innovation is created out of another innovation and how they develop is very important. And then when you think in terms of that, in principle, you can think about an abstract space of all the possible innovations which are being conquered by actual activation, by actual discovery of this pre-existing stuff, like in the product space that I was showing before. But the actual situation is different, because imagine if you have this space of innovations, then if you have a lot of agents which are a lot of, let's say, people or companies which are populating that node, which are, with the interpretation would be that they adopted this innovation, they are working on it, they are producing based on that. Then if there are many of them, then the probability that there will be new innovations which are related to this one, which are appearing in the network, would be much higher than if you had just somebody very isolated exploiting that innovation. Therefore, the appearance of new innovation should be thought as the appearance of new, genuinely new links and new nodes, rather than the conquering of the old nodes and through the old links by some agents which are living on the network. That is the main idea which is the start of this lecture, and which I'm going to start developing a little bit in the next minutes. Yes?
The model that you showed, it was all the firms in Italy specifically, and nothing outside of it? And it's regardless of what kind of firm it is?
I just before the lecture, I took out some other graphs which were containing what we call hedge firms and Ponzi firms. I'm going to discuss them. Hedge firms are firms which are capable of returning the loans which they have made immediately. And there are some other kind of firms which are speculative ones, which they cannot return the loan back, like we cannot return immediately the loan which we took for our houses, but it's enough that we are able to pay the interest for those loans. And there are what is really dangerous for a firm is when a firm that cannot even pay that, and they are called Ponzi firms. And as I said, I just took out the graphs from there, but there you see even more dramatic graphs than what I showed before, in the sense that for the hedge firms, you have a much stronger decay. So even the firms which are surviving, which are not disappearing, they are actually lowering their status. And on the other hand, the Ponzi firms, the ones which are endangered, they were pretty low in this region, and they increased very much. So indeed, that's exactly the point, that one should look more carefully to that. Now, in terms of looking to more countries, that is a very good idea. However, all this data, we were extremely grateful to people which provided to us, because they are privately owned. And on top of this, even dealing with this data is extremely difficult, because we are not supposed to see the bank accounts of private persons. So therefore, the way we are accessing the data is in a kind of collective way, and such that only our coworkers, which are the employees of the bank, are seeing stuff which is which we shouldn't see it, because we do not want to violate the privacy of people. So this kind of social measurements are nowadays on one hand very important, because they are promising to give us control on the economy in the same way, hopefully, as we have control on the boiling of water or things or other phenomena like this. But on the other hand, they have their own problematics, and in particular, if one of the bank conglomerates, even the biggest one in a country, gives you the data, it doesn't mean that somebody in another country would give you the same data. And even if they give it, they are very incompatible. Each country has different conventions about what is written there in their data. So
maybe the problem is not the assumptions, it's just that the boundaries are not very well described.
If
it's like if you just take Italy by itself, it's like you measure the boiling of water, but outside everything is boiling hot.
That,
and you say, oh, the problem is with the model.
You might be right, and this is an entire profession. This is the difference between a first degree course and an advanced course, which I'm giving elsewhere. And I hope that some of you will indeed be interested enough in order to advance that more careful study of this. But definitely the export data is important. In principle, we have some control on it, because if you look at this, there is again some bulk of data which is again private, but not it doesn't suffer from privacy problems, because they are companies which are traded officially. And there they have also some of the columns in this enormous balance sheets are about their trades with the external world. So it's not completely unknown. But it's indeed a very good point. And treating a country isolated is definitely not correct theoretically. And so there is an entire science, so to speak, about how to do that. But you know, typically when there is an entire science to do something, it means that people don't really understand it. When people understand it, it's already technology, not science. And you don't care, you don't teach it in the university anymore. So the mere fact that I'm teaching it in university, it means that there are very many things which are not cleaned at all. So one of the things which people have in fact advanced about new innovations is the fact indeed that, as I said, if you have a certain node which represents some innovation, then there is a certain probability that some innovation which didn't exist even potentially before is going to be created. Or even something more sophisticated, in which two innovations which are in principle different, they can be brought together in order to create a new innovation which would be part of this cascade of new investment. And if in the old economy you would think that the innovations is, you know, some kind of smooth natural growth of a system which maybe can be considered as a stationary system, and with a little bit of addition to it. In the modern economy, it is actually the case that this kind of appearance of new products is the very engine of the economic system, and it accounts for most of the growth in the economics systems. For instance, in this country, 50% of the exports are high-tech exports, even though a rather small percentage of the population is engaged in that. So it becomes important to treat this kind of things. Once, what was very surprising for us is that once you start thinking in terms of these abstract structures in which formal network kind of structure is analyzed formally and mathematically, then you find that very, very, very different things, starting with production, going through the structure of the structure inside the brain, structure in the immune system, but even going down to very humanistic fields are obeying very, very similar mechanisms. And this is what I'm going to speak today about. And in a sense, this is why I decided that this is a good course to give to this situation in which the class it's not a class of mathematicians or physicists, but it does have people from humanistic studies, from philosophy, and in which this kind of phenomena seem to be appearing too. It's just that most of the people which are specialists in that, they are not exposed to the kind of technique which I'm expressing now, and it is my hope that once they are, then they could apply this to those fields and transforming them into much more powerful in terms of what can be predicted, what can be said, what can be improved about this kind of humanistic things, because it's not, usually one says the word humanistic studies, but in principle you can have a more aggressive in quotation marks attitude and actually having humanistic intervention in terms of trying to, for instance, improve the culture of a certain country, the behavior of people in a certain country. In our country, we might think in terms of bringing together the people which are coming from so many different cultures. More than we have 7 million people coming from about 100 different countries, and it is not trivial to make sure that they can work together in an optimal way, and still each of them maintaining the parts of its identity which are important to it. And a similar situation happens in Europe, in which on one hand each nation is entitled to preserve its identity, on the other hand it is very important that they will work in harmony together. So this kind of mechanisms are expressed most of the time in terms of mathematical formalism, but in this lecture, and as I promised in the most of the rest of the course, I will try to play down a little bit the mathematics and concentrate on the mechanisms. And whoever will want to deepen one's formal understanding of it, then this can be done. So let's start with some work which you have heard maybe about. Who didn't hear about the 6-degree separation idea? You didn't hear about that, and you didn't. You did? Okay, so there was some, I think it was a sociologist, maybe psychological, social psychologist in the 30s, I think, Milgram. He sent letters to people with some address, except that he didn't send them to that person. He sent it to another person on Earth, with the instruction that that person would pass the letter to somebody which he hopes that would be closer to the person to which the letter was addressed. So let's say he sent it, the addressee was some professor in Massachusetts, but he sent it first to Bangalore to maybe a professor in Bangalore, but maybe cook in Bangalore, and then the cook was supposed to send to somebody which he hopes it's better position to send it to yet another person, and eventually the letter will end up with the guy in Massachusetts. And in principle, you can think that this is going to be a very long chain. And now a little bit I gave away how long was the chain, but still, what is your guess? How long was the chain until the letter got to the right place? It was 6 people. So, so this was pretty surprising, because after all, if I'm asking you what is the average of the distance between you and your neighbors, then the average is probably a few hundred meters, especially if you live in the dormitories. So the question is, can you find geometry of the social interactions in which on one hand each person is connected to persons which are in its immediate neighborhood, and that also means that essentially what is said if you have two friends which are in your immediate neighborhood, this means that they are also one in the immediate neighborhood of another, and therefore it's very probable that they are friends too. So you have this kind of the friend of a friend is a friend situation, which it's called clustering. It's measured mathematically by clustering coefficient. So you are asking, how come that I have a system in which the clustering coefficient or these connections are very local, and on the other hand, when I'm sending this kind of letters as Milgram did, I'm ending up within a very short chain to the right person. So this question was asked by Duncan Watts and by Strogatz in the 1990 or something like that. And they came with the following mechanism, and this is where we are starting to probe this concept of how a network, what is the dynamics of the network itself. So they said, what happens if in this kind of a network I'm erasing one of the links and I'm making the link to very far away? Like for instance, my best friend from the high school, he moves, his parents are moving to New York, and now it's not anymore true that I have a friend next to me. The friend is far away. And of course, if everybody, if I keep doing this too many times, then eventually I have a situation in which all my friends are not around, which in my case is true because I was born in Romania, and then it's not a network like this at all. But their discovery was that even if you have a relatively small amount of links which are being substituted by long-range links, you still get a situation in which, on one hand, you are still having most of the neighbors of a person very close to itself, and neighbors of neighbors are neighbors. The clustering coefficient is still not small. It's pretty strong. And again, the proof that you can go on Fridays evenings together with your friends, and you are all together. So clearly there is a clustering there. The concept of clustering, by the way, is very important also in these innovation systems which I was describing. They are the central question of how these clusters appear, how the Silicon Valley kind of cluster appears, how the Israel in the high-tech cluster has appeared. It became very famous. Even some people wrote a book which is called Startup Nation. So this kind of clustering of people which are related to one another, and on the other hand, the smallness of the world in terms of the fact that already in the 30s there were only 6 steps that you could span the entire Earth, not to speak about today. That paradox has been solved by these people, because if you do this rewiring, it is still true that a neighbor of a neighbor is a neighbor. But it is also true that in place, for instance, in place of having to go from here to here, and you have to make a number of steps which is proportional to the distance between a person. So if I would continue with 1 billion people here, then getting from this one to the end one would be half of a billion, because each step is twice. So, but it's still half of a billion, not 6. But with this kind of situation of rewiring, you see that, in fact, the number of steps can be very highly reduced. And, in fact, it can be proved mathematically that the diameter of the world goes like logarithm of the number of nodes which are involved, which is starting to be of the right order of magnitude, because even the logarithm of 1 million, it's 6 or something like that. So this this construction was explaining it. So in terms of the network itself, these networks are indeed much more realistic than you know, the square lattice which I was describing in a previous lecture, or also then a completely random network in which each person is connected randomly to somebody else. Because if each person is connected randomly to somebody else, the probability that two people which are connected to you will be connected among themselves would be essentially 1 over the number of people in the system. And if you have billions, it's 1 over a billion, it's basically 0. So you wouldn't have this kind of clustering. But on the other hand, this kind of erasing a link between two neighbors and throwing it away, it's not very realistic, and it wasn't confirmed experimentally. Before going to what is confirmed experimentally, I should show this graph, which shows essentially it's a graph about actors and actresses which are appearing in the same movies. I'm not speaking about stars. I'm speaking about you know, tens of thousands of people which may appear in some super production. So it's not that I don't know, yeah, it's not like the kind of explanation you can get to this is not like, oh, Sylvester Stallone and Schwarzenegger are friends with George Clooney, and therefore they brought him to the same movie or something like that. It's not at all like this. It's about tens of thousands of people which are selected by whoever is in charge with the cast. But you still see that if you look at the network, if you look at each of them, how many people they are playing together in a movie, they have this kind of power law, which we have found in many other systems, which we have discussed during the course. And then the question is, can you explain why the networks will have this kind of behavior? And here, of course, comes the kind of computations which we have done in the previous lectures. In which you remember that we, whenever we wanted to explain the appearance of a power law, we said maybe there is some kind of autocatalytic process in which the number of neighbors, let's say, once you have many people which are playing with you, then you will have, the next time you will have something proportional. The number of new partners which you will have in the next movie would be proportional with how many you already have, which makes kind of sense. So in fact, this was formulated in terms, because not only this actors network which we have studied, but many other networks have these properties, it was proposed that if you think about a network, and now you think about some, this is a very large network, but just pedagogically I'm singling out 3 different nodes out of them. And so this is the rest of the network, and these are 3 different nodes. And now, as you see, this one has 2 neighbors in the cloud, and one of them a third one, so it's 3 neighbors. This one has 6 neighbors, 4 in the cloud, and these 2. And this one just has 1 neighbor, that one here. And then the question is, can I find a mechanism for updating the network which would reproduce this power law, which we have been measured? And of course, based on what we have learned in the previous lectures, you have a situation in which you are saying, okay, so each time there is a new node appearing and it wants to connect to the existing cloud, it will choose each of to connect to each of the nodes with a probability which is proportional with how many links they have already. So in this particular case, if this one has 3, then it will be proportional to 3. This one would be twice as probable to be connected by this guy, and so on. And of course, formally, this would mean that the number of neighbors of a certain node, let's say this one or this one, at time t plus 1, is proportional with how many neighbors it had before at time t, times a random number, which is the only condition is that this number would be the same for all. That I'm extracting with the same from the same probability this this factor, whether I'm acting on I'm judging whether to connect to this one, or this one. And if I do that, then this formula we have seen 100 times. We know that this ensures that the number of neighbors fulfill a power law, which means that if I make a graph, a double logarithmic graph on which on the x-axis is the number of neighbors and on the y-axis is how many sides have that number of network, then I get on such a logarithmic scale a straight line. And as you have seen, very much similar to what is in nature. So if we want to describe this kind of networks in reality, and if we want to understand how they are created, and as you see, it's not just a mathematical exercise, but it's of great importance for trying to understand how economies grow, how societies are being transformed. Then one has to try to understand how the networks are being created, how they grow, how they transform. And actually, it turns out that these two mechanisms, which I mentioned before, they weren't really, in very many of the networks which we have measured, they weren't the main mechanism by which a new link would appear. Rather, what we have found is that if you have a situation in which, let's say, two nodes are connected to a third node, let's say there are two internet sites which are linking to a third site, or there is a third site which is pointing to two different sides, then there is very probable that a new link, whether in this direction or in this direction, will appear with a much higher probability than a random probability. So here we have yet another mechanism which turns out to be confirmed by the data in quite a number of networks, in which the rule is that similar nodes, similarity in the sense that they are behaving similarly towards a third node, they are very likely to get connected in the next step. So essentially, there are a few ways to think about it. One of them is that nodes which have a common neighbor, they will develop a link between them. Another way is to say that if you have a node which has a lot of neighbors, then there will be a high probability that the neighbors of himself will become neighbors too. So it's in a sense fulfilling automatically these requirements which we were looking for a mechanism that a neighbor of a neighbor is a neighbor. What is really interesting that it also fulfills the scaling law. You get not only the small world characteristic of the networks seen in nature, but you also get the scaling. You can also think in terms of autocatalysis in the sense that these two links are catalyzing the existence of the third link between the three nodes which they are connecting. And as I said, this procedure does fulfill the measured conditions which I was speaking before. But in fact, these are not the only properties of the existing networks. They are the most easy to discover and to put in evidence. But the question is whether you can understand in more detail how the networks are behaving and how they are growing and how they reach the structure that which we are witnessing in nature. And I'm going to, from now on, I'm going to discuss in the remaining of the lecture. I'm going to discuss this diagonal links, and you'll see that they are active in very many different domains. But in the meantime, I want to describe to you what is the kind of measurements which one has to do in order to indeed discriminate between situations in which the diagonal link is indeed the dominant mechanism and situations in which maybe it is not. Now, before this work which was asking how a new link will appear, according to which rules, what can increase the probability of a new link to appear in a particular local configuration, already people have studied the issue of what are they were called the motifs which appear in a network. So in place of course, we are also interested in the global characteristics of the network, but we are also interested whether, let's say, triangles or squares or hexagons are more likely to appear within a network or not. So what I'm describing here is a generalization of it, because I'm not asking now whether a triangle is likely to appear. I'm asking whether the presence of these two links will induce another link like this. I'm not describing whether I can have a situation in which there is one link here and two links in different directions connecting these points. But I'm asking whether in the case in which this one exists and this one exists, whether this appearance of a new link there is more probable or less probable than just random things. So, of course, the question is that B and D are in fact diagonal links in this respect, while C and A are not. So you can go to a real world network and see it in studying its evolution in time, whether it is the A and C kind of additions of links which is dominating, or whether it's B and D. And of course you can go, these were three nodes configurations within the larger network, but you can think about 4 nodes, and then you have more possibilities. Like, if you have these 4 links, what is the probability that such a link will appear? Or if you have this no, these were 3. If there are these 4 links, what is the probability of this to appear? And again, you see, in the case of E, this is not having any diagonal link, because these are only indirectly connected. These ones are diagonal links. These ones, C and D, are in a sense doubly diagonal, because they close not only this triangle, but also this triangle. And this one is closing this triangle and this triangle. So you will see that the measurement shows that more triangles a link closes, more it is probable to appear. So this is, for instance, a situation in which you start with 2 guys which have 1, 2, 3, 4 common neighbors, and therefore this link would close 4 triangles. So in the case of the actors, you are essentially going to check whether, in the case in which actor 3 was acting in the same movie with actor 1 in some movie, and actor 2 and actor 1 were appearing in some movie, what is the probability that let's say this happened in the last year, what is the probability that this year actor 3 and actor 2 will appear in the same movie? And this is the answer. You see, if the number of common neighbors, or in this case, if two actors have one certain, they don't have any one certain actor which plays together, then the probability for them to play together is proportional essentially to random. To a rather low probability of any two actors in the world playing together. However, if they already have one actor, one common actor which played with each of them together, the probability goes up by a factor of 10. And if they had two, then it gets up by a factor of 100 or even more. And this is for actors, but it's the same for actresses. It's the same for links in Wikipedia, for networks of routines calling one another in software, and also for sites in www. And to see how much stronger this diagonal link mechanism it is, you see that here, by just going from 0 to 1 to 2, I go by 1 and 2 orders of magnitude more probability. While if I'm just thinking in terms of the degree of the mechanism which we were discussing before, that there is some additional probability that if I have a certain number of neighbors, then the next person which appears will connect to me with a higher probability, then you see that in order to have the same one order of magnitude, getting to the frequency from the average random frequency to 10 times more, I have to go with the degree, with my number of present neighbors from 10 to 1,000. So it's a much weaker thing. The same factor of 10 I was obtaining just going from 0 common neighbor to 1 common neighbor, and here I have to go from 10 neighbors to 1,000 neighbors in order to increase the probability that somebody will attach to me by a factor of 10. Is this discrimination clear between the two mechanisms? One mechanism is about completing a triangle, essentially. The other one is just saying that your probability of being attached by a new guy is proportional with how many friends you have already. And for this, you see that you have to have 100 times more neighbors in order to get a probability 10, while in the previous case, it's enough that you have just one common neighbor. That already increases the probability by 10. And the next one by another 10, and the next one by another 10. So we are seeing that experimentally, definitely this diagonal link is a very important thing. But from now on in the lecture, I'm going to develop this theme and show that actually it is not important mathematically, but during the history of many of the domains, people have identified this diagonal links as the very soul of the dynamics of the development of the systems. But before that, I would like to make another point, which is rather interesting. You see, I was saying that if two E-sites are pointed out by a third site, then they are likely to connect to one another in the next time unit, either by a link in this direction or by a link in this direction, or maybe both. And the same thing is if two sites are pointing to the same site. However, what it turns out, and this is why it is important that we have measured the dynamical motives, in this sense, that I'm asking not what is the final configuration which can appear or cannot appear in a network, but I'm asking whether a particular link would appear given a certain neighborhood or not. Why? Because, for instance, if I have a motif which is like this, this one pointing here, this one pointing here, and this one pointing here, then in principle this can be created in two ways: by having these two links pre-existing and having this one appearing. In this case, this would be a diagonal link. But it could be appearing by this one existing, and this one appearing. That is something new, because this one is pointing to this, but this one is pointed by this one. And in principle, that you might find reasons why such kind of thing will happen, because you can say, okay, the owner of this site has a link to this site, but this site has another link. So in the moment that he made the link here, he looked in the other links which this guy has, discovered this guy, and made another link. And maybe this is a very probable thing. Well, it turns out it's not. This kind of dynamics, in which you have this, and you are creating this, it's not very probable.
But this is necessarily, the link is only one direction?
No, in principle, why?
I mean, this is what you show here in the model, that when the link is one direction to the E site number 1, and then in one directional to E site number 2, so it's that. Okay, in the case that they are not directional, of course, this kind of discrimination cannot be made. And then it's another game. But I'm making the point that in the case in which these are directional, like in the case of E-sites, then it's a matter of experiment. What is the mechanism which leads to a certain configuration? So this kind of configuration, this, and this, it can be obtained by two different mechanisms, and only one of them, a posteriori, after measuring them, only one of them is effective and the other one not. But and this is trying to understand the difference between this slide and the two before.
Oh, look here. Here there are two guys which are pointing to the same guy.
So the direction is important.
It's very important. That's what I'm saying. The direction it's terribly important in this particular case, and it is also important that you are measuring in time what is going on, because after this link has been created, you could interpret the existence of this kind of a triangle both as proof that the diagonal link exists, but also as a proof that this kind of transitive link exists. That if I'm friend with this and he's friend, I'm pointing to this and he's pointing to that, then I will point to that. Which is it happens not to be true. If you ask me why it's not true, I'm not so sure. And this is, of course, the next step, to try to understand, also asking people, or I don't know what. But already it's a great advancement that instead of looking at pictures of networks and just trying to give dynamical models which maybe explain how they look like, now one is measuring what actually takes place. Yes?
Previous slides, how can you determine the timing of the creation of the links? How do you know that the first links were like this, in this direction?
This is the beauty of nowadays internet, but of nowadays almost everything. In the case of the internet, of course, you know when a certain link has been created. You know it very well, and the question is how often you check, for instance. But you definitely know it, yes, and it's important. Okay, so we actually first stumbled upon this kind of things together with Janko Goldenberg and Dudi Mazurski in the context of creative new ideas, which I'm going to discuss in a short while. But in the meantime, I want to point it out that the message is not that we discovered something new. it's very old. The most celebrated thing is, of course, the discovery of Ivan Pavlov. He was keeping his laboratory by selling, I don't know if saliva of dogs or just their stomach sauce, secretions. Huh? Acids or something like that. But the point is that he noticed that if he is ringing a bell whenever he gives them food, then after that, just ringing the bell without giving the food is already enough to it's connected by the dog to salivation. So, of course, this would improve highly his production of saliva there. So, if you think that sometimes that always the great discoveries are the product of theoretical interest, it's not always like this. He was just producing saliva or other liquids, I don't know exactly what. So this kind of diagonal link is definitely not something that we are discovering. We are just rediscovering in the context of putting it in the context of networks and in the context of the fact that we have much more data than people had before. In fact, this idea came not only at the macroscopic level, in which you have a dog and which is intelligent enough to connect two things which were connected to a third one. But it happens also, or at least it was claimed, that it happens at the level of neurons. There is the Hebbian rule, which is very intensively used by people in neural networks. I'm not sure whether it was yet confirmed experimentally, but this is beside the point, because you'll see that towards the end of the lecture, or maybe the next lecture, depends how fast I'm going to make the hypothesis that maybe the fact that we are finding so many diagonal links in nature is because we are wired inside our brains to make this kind of connections. That our entire construction of the world, in the constructivist sense, is dominated by this pattern. But in any case, in the case of Hebb, already, I think it's already 40 years ago, he said neurons that fire together wire together. So whenever you have some impulse from outside which creates, let's say, both eyes or two pixels in the eye to be fired together, then the neurons which are corresponding to that perception would have the tendency to be connected together. And as I said, this is being used very intensively in trying to reproduce the kind of neural structures which are realized either in nature or in the models of neurons. But if you think that this is a product of the last century, then one is wrong. Actually, in the 1600s, Spinoza wrote something. I have to change a little bit his language because it's very different from the way we are expressing ourselves today. So this is my slight change in his expressions. He says, if an object resembles another object which is pleasurable or painful, although the point of resemblance be not the cause of pleasure or pain, we regard the first object with love or hate. And essentially, he was claiming that this is the way we are constructing our entire internal lives. That at the beginning we just like the milk from the mother, and because of that we like the mother because it's related to the milk. And then because the mother is related to the father, then we might like the father. But of course, sometimes the father, it's by his behavior, it's only taking away the mother. So one can both hate and love the same person. This is not ruled out by by his structure, by his construction. So you have this kind of mechanism. He also said, applied it also to the emotions in the following sense, which is very, very similar to Hebbian rule, except that it is at the level of emotions and not of neurons. He says, if the mind has once been affected by two emotions at the same time, it will, whenever it is afterwards affected by one of the two, be also affected by the other one. So this diagonal link has been observed also by Spinoza. And of course, Spinoza wasn't a psychologist, but at the time, all the sciences were mixed together. But the father of modern psychology, William James, he also made an example of this type. He said, if, for instance, I think of Paris whilst I'm hungry, I shall not improbably find that its restaurants have become the pivot of my thought. So again, you have this kind of very basic unit of thought, which is reappearing in whenever people are thinking about how people or other things react. Now, the point is, however, that you might say, okay, so our mind is special. Maybe there is something to do with the fact that we have memories, that our brains are wired in a particular way. But actually, already quite a number of years ago, it was found that there is this kind of connection between the nervous system and the immune system, because the chemicals which are governing both of them, they are endomorphins, essentially morphine. One of them is morphine. So no wonder that people are claiming that your state of mind is affecting your health. But again, maybe this has to do with our illusions. Another experiment which is very dramatic in this sense, it's the following. Some biologist, immunologist, has wanted to see what happens with mice which are prevented from having a strong immune response to antigens. So then he gave them some immune suppressing drug. Of course, it didn't have a very good taste, and because of this, he had to give, like we give to our children, if you give them some medicine, then some of them, they are flavored with raspberry flavor or things like that. So he also gave them to the mice. He gave some sweet and tasty liquid when administrating, together with a drug. But then it turned out that, and of course, the immune suppressing thing caused the immune reaction to antigens to be suppressed. But what was really surprising is that when he administered only the tasty liquid, without the active ingredient, it still had the same effect on the mice. And of course, the mice are double blind, what is called in terms of experimental science. They weren't informed that this is going to suppress your immune system. They didn't know anything, and still they had this effect. So nowadays, when people are saying, usually people are saying about a drug which is not active, it says it doesn't have an effect above the placebo. Well, it turns out that the placebo effect it's a real one. And it doesn't have to do with people convincing oneself that this effects. And this brings us to actually the kind of observations that brought us to pay attention to this diagonal links. This is an advertisement for explaining that Nike are cushioning very well your shocks at the feet. So you see, they try to transmit it by actually showing that some firefighters are holding giant Nike as you will hold sheet, how is it called? A blanket, this kind of blanket on which people are jumping from fires. So, so the kind of structure which we have found, and it's not only in this, you'll see that it's extremely pervasive and it's extremely powerful, is that if you want to connect in somebody's mind shock absorbing with Nike Air shoes, then the right thing is to present them with this kind of picture in which both something which is shock absorbing like LifeNet is put together with a Nike shape. And this kind of technique has been, we have found that it has been applied in almost virtually almost all the celebrated advertisements, the ones which got the prizes. They have yearly competitions about that. And you see a few more examples of that. Actually, it worked very well because I actually bought ballet shoes, but unfortunately they didn't fit me. So in this case, this is one for explaining that a cigarette leads to death. This is another one against smoking, and so on and so forth. And this is the first idea of an advertisement which was created by a computer. By our computer, we wanted to check whether by applying this kind of scheme we can automatically generate a new idea. And before having it programmed, we had do it automatically, but still by hand. After that, we generated them by computer. So these were the ideas were generated by computers, but the pictures themselves were done by some graphic people from New York Times, because of course you can imagine that if a group of people wrote an article in Science magazine about the computer getting better grades than the humans in creativity, then all the general literature, general publishers got interested in that. Some other some other ideas, some of them are actually were not very good ideas. The poor computer is not very sensitive to cultural problems. So the computer came with the idea of having the Temple Mountain having the texture of a tennis ball in order to advertise a tennis tournament in Jerusalem. Definitely we wouldn't have recommend that. Also some other program came for the same advertisement of well, I shouldn't give all these blunders of the computer because the lecture is recorded and I don't want to offend anybody. In any case, these ideas from the computer were presented together with ideas which were produced by groups of people. They were presented double-blind to another group of people to give them marks. And as you see, we didn't expect, of course, that the automatically generated ads will make better than the winning ones, because we constructed them according to the winning ones. So it's not, we didn't expect to do better, but they do slightly better, not really within, I mean, it's within the error bars, but slightly better than the typical ads in magazines. And what is very important, they definitely do much better outside the error bars than normal people. That you just get a group of people and ask them to create some advertisements, let's say, of a world tennis tournament in Jerusalem, and they would come with some ideas, and the computer would come with some other ideas, and then you get them judged by a third group which doesn't know which ideas belong to the computer and which to the humans, and there is a very big difference between their marks. We also applied it to creativity in pictures. So the way we did was the following. We took photographs which we knew that they got the prizes in tournaments, and we tried to identify the diagonal link structure of them, and then to emphasize the characteristics which are related with this, and see how the subjects are giving higher or lower marks as compared to the original one. So in this particular case, of course, the main point is that, in fact, in this kind of things, it's a double diagonal link. It has to be both a direct diagonal link and a contrast one. So in this case, you see that on one hand, they are all of them children, and of course you think of them as children, but there is this one which is standing out, and of course emphasizing that the color doesn't matter, but the color is there to make the point that the color doesn't matter. And because of that, when we emphasize the difference in color, this got maximum originality marks, even higher than the original photograph and higher than the others, especially the ones in which this point was lowered. This is also applied to narratives. In fact, one of the students which was doing a master with me at that time just wrote to me an email that he wrote an entire book about the fact that people got successful and famous because when they are good at presenting narratives to their peers. So here what we did was the following. We were looking for diagonal links in a story. And we were looking especially in a story in which we knew that the author said that there is some kind of hidden meaning. It was a story of the princess of, just a second. Yes. Just a second. Yes, there is a story of Rabbi Nachman of Braslav about the lost princess, and we were lucky enough that there is this story in terms of the ostensibly it's a story which is identical with the story of Ukrainian popular story. They have exactly the same, if you look on the surface, they are exactly the same story. Except that we were looking for diagonal links whenever in the story. For instance, the story starts with the king playing with his daughter and saying in a joke that let the no good take you. And then the next night, the no good takes her, and then so this is the first diagonal link. Then there is the next one appearing because the second in command from the king decides to go and look for her. So this is a third diagonal link, but because she looks for her, he actually have to look for the no good, which took her, the fourth diagonal link, and so on. And we made the statistics, how many diagonal links you get and where. And in the popular story, there were quite a number of events which were no diagonal links, but all the events in the story of Rabbi Nachman were like that. Moreover, we look at the density of diagonal links, and they were twice as many in the story of Rabbi Nachman. But the real dramatic measurement is the following. This story, like many of his stories, had many commentators. So we found 21 classical commentators, authorities in this kind of semi-Kabbalistic, I don't know how to call it, stories. And each of them had discussed some events in the story. In total, there were 29 events which were discussed by the specialists, by the relevant commentators. And then we ordered the different events in the story according to how many commentators have connected to it. So we look at the diagonal links, and we said, okay, so are there any commentators which related to it, which made it as a very important step in the story and as having significance in the narrative. So look what a dramatic thing. The first 12 in the list of how much commentators were connected to them, they were all of them diagonal link. There was one which was in the middle, and then the last one in the diagonal link is number 14. And from this, and then all the other guys are with much less. So clearly, I mean, the non-diagonal links and the diagonal links are clearly separated in terms of how significant those events were considered by the commentators. And but you don't have to go to this kind of hidden information. The kind of this pattern in which the very beginning of the story is related with this kind of contrast between two entities which are connected to the same person appears like in Romeo and Julia, in which she is both an enemy and a lover, and in Oedipus, in which he is a good king but also a parricide. In the Trovatore, in which he is a loved son but also the son of the enemy. In Little Red Riding Hood, in which essentially the wolf is gets connected, and in fact it's the grandmother, because of both of them, they are connected to Little Red Riding Hood. In Henry V, again, both enemy and spouse. In Cinderella. So, probably if I would give this lecture on the other campus, I wouldn't give this examples from the literature, but I think that in fact this study of the Rabbi Nachman stories was done together with Moshe Idel, which is the leading researcher in Jewish thought in the world. But typically we, since not always one is fortunate enough to have a partner in the humanistic field, which definitely I would like to continue to do, we applied it also to the creation of new products out of old ones. So it's again returning to this kind of, I wouldn't call it obsession, but this extremely intensive attention which the social sciences and the economics field are attaching to novelty, to innovation. So the question is whether you can have some kind of automatic method of creating innovation. And again, it has to do with this kind of structures in which you can have different elements of the structure, and you can, in fact, substitute for one of them the existence of the other one. Instead of having the initial structure within the conceptual structure of the product, you can construct a new structure which has another scheme, and then transfer that scheme into the reality. And there are, an example is, for instance, how people could have invented helicopter. It's not that it was invented in this way, it's just an example. We do have a lot of examples of things which were invented in this way. But so the point is that in a normal aircraft you have a rotor which is providing the force for advancing the aircraft. But there is also the wings, which are providing the support for the aircraft. And there is a force which is applied by the rotors such that the wings can support the aircraft. And the point is that you can get away with the, without the wings by just having the rotor support the aircraft instead of the wings. So this is a kind of scheme, a conceptual scheme, which in fact have been used, and it's being used not only in technology, but in many other fields. Like, for instance, you remember that Lincoln has essentially if not devised, proclaimed the new type of government in which, rather of having a government which is which is based on the nobility or the king governing it, you have a situation in which I'm sorry, in which the government is of the people, by the people, and for the people. And I think that my time is finished here. In the next lecture, I will try to finish with describing some other implications of this dynamics of how new nodes and new links appear, and how one can understand the functioning of different systems in this context. And also the social organization based on the same, and also there is this kind of structure which has to do with the emergence of high-tech structures between different companies and different people which are active in such things. We have to stop for today.